Okay, today we're finishing section 7.6, the last section we're going to do on similarity. Going to go through a lot of definitions here. Pause the video when you need to. The definitions are in the front of 7.6 in the textbook. They're close, they're not quite identical. So, let's go. A transformation is an operation that maps an original figure, which we're calling the pre-image, onto a new figure called the image. Big thing I want us to be sure of. The original figure is called the pre-image. The second figure is called the image. A dilation. A dilation is a transformation that enlarges or reduces the original figure proportionally. Okay? Very important. The dilation is going to give us similar figures because it's done proportionally. Similar figures have proportional sides. A similarity transformation is a dilation that is a type of similarity transformation since similar figures are produced. Okay? So, a dilation is a similarity transformation. And finally, the center of dilation. Dilations are performed with respect to a fixed point. Oftentimes, this fixed point is the origin, 0, 0. It's not always the case. Finally, the scale factor of the dilation. That is the ratio of a length on the image to a corresponding length on the pre-image. Remember our definitions. The pre-image is what we start with. The image is what we finish with. The scale factor is going to be the image over the pre-image. Very important. We're back to this example of if you had one side of 5, one side is 4, and you did a scale factor, well, not both 4/5 and 5/4 are the correct answer. In this case, the length that was on the image, what you ended up with, has to go on top. The length on the pre-image has to go on the bottom. Let's look at this example. What we have happening here. First of all, we do have a center of dilation at 0, 0. Our original pre-image is triangle ABC. That's our pre-image. We end up with triangle JKL as our image. So, first of all, we would say that JKL is a dilation of triangle ABC. And something I want you to see that's happening here because it'll help you on problems later. If we took a ruler and made it so it went through the origin and one of the spots on the pre-image, one of the vertices, that line would also go through the vertice of the image at every point. So it'll happen for A, for B, you'll notice it goes through K, and for C it goes through L. That's actually going to help us simplify some problems later on. Finally, our scale factor. We could use any of these sides since they're all proportional. So the length of JK over the length of AB would be our scale factor. We're going to find that that's also going to be true that KL over BC or LJ over CA is also going to give us our scale factor. It'll all be the same number when you reduce. Okay. Last set of definitions. An enlargement. An enlargement is a dilation with a scale factor greater than 1. It produces an image that is larger than the pre-image. And this kind of makes sense. If we took all the sides times 2, we're going to end up with a bigger image. A reduction is a dilation with a scale factor less than 1. It produces an image that is smaller than the pre-image. If we took all the lengths times a scale factor of 1/2, we're going to end up with smaller sides. So just a couple quick examples. Here we have an enlargement. A is the pre-image, B is the image. Notice that B is bigger than A. All the corresponding sides will be bigger as well. Here's an example of a reduction. A is the pre-image, B is the image. So we took all of A times the scale factor and we ended up with an image that was smaller. Okay, go ahead. There's about 4 example problems. Work those out. Look through examples in the book if you need to. Pause the video. You can restart and I'll go through the answers to those problems. Okay, first one, a photocopy of a receipt is 1.5 inches wide by 4 inches long. By what percent should the receipt be enlarged so its new image is 2 times the original? Well, if we double something, 2 as a percent is actually 200%. Okay, just something we need to know. What are the new dimensions? Well, if our scale factor is 2, we take all the sides times 2. So our new dimensions, 1.5 times 2 is 3. 4 times 2 is 8. Now, watch what the question's asking. It might ask what the new perimeter is. It might ask what the new area is. But once you know these dimensions, you can figure that out. All right, let's go to the next one. Okay, on this one, we graph the original and dilated image. Verify it's a similarity transformation. I had an original of ABC. I graphed that down here in blue. And the image in DFG, and I graphed that in green. This is a good one to look at. Use a ruler. See if 0 is your point of center of dilation. And you'll notice that for BF, it's obviously true that there's a line from the origin through B that hits F, and a line from the origin through C that hits G. I didn't quite get this to scale, but if you graphed it correctly, you'd see a line from the origin through A is going to hit D. So it is a center of dilation of 0. So you have 2 options here on how to do this if you want to verify it's a similarity transformation. If it's similarity, corresponding side lengths are going to be proportional. That's what we've worked on the whole time. But if it's centered of dilation is at the origin, we have a shortcut. What you can do is look at every coordinate here and line them up. Okay? A corresponds to D, B corresponds to F, C corresponds to G. Notice that every time I went from A to D, I went times 2. All the way across, and you can verify that on your own. If we multiplied every single number, x and y coordinates both, by the same number, it is a similarity transformation. And you're done. That, in some cases, is much easier than doing all of the distance formulas. We'll do one next that requires you to use the distance formula. Okay, on this one, you were just given 5 points. You weren't told what the image and the pre-image were. But if we start drawing here, we're going to notice that we end up with something that looks kind of like that. So ABC is our pre-image, and AED is our image. And this actually could have went both ways on this one, but all we have to worry about is whether it makes similar triangles. All right? So all we have to check is, do we have at least a couple of sides that are proportional? So we have AC to AE is going to be proportional to AB over AD, which is going to be proportional to BC over DE. AC had a length of 2. AE had a length of 8. AB, we'll have to do a little bit of distance formula here, but 3 minus 2 is 1. 1 squared plus 2 squared is 5. 3 minus 2 is 1 squared plus 1 minus 1 is 2 squared. We put that over AD. 3 minus 1 is 4 squared plus 1 minus 7 is 8 squared. That's already looking a little funny. Let's take a look here really quick. 1 squared is 1 plus 2, that's 4. That is square root of 5 over 16 plus 64. That's going to give us the square root of 80. And We'll take a look here, do a little calculator work. Square root of 5 over the square root of 80. All right, and that actually does turn out pretty close, that it is still actually 1/4 if we reduce this. So we're okay there. Let's look at BC. 1 minus 2 is -1. -1 squared is just 1. 1 minus 2 is -1. I'm sorry, that I did already. 1 minus -1 is 2. 2 squared, which is 4. All right, now we do DE. -5 minus 1 is 4 squared. 1 minus 7 is 8 squared. We're going to get square root of 5 over square root of 80. All of those are the same number. This will all reduce down to 1/4, and therefore, yes, this is a similarity transformation. Last one I want to hit real quick. We need to find the coordinate for B to make this a similarity transformation. What I want you to see here is when we get it into a picture, it sometimes simplifies. Notice that this side length up here is 4. This length up here, all the way across, is 12. This length down here will be 6. We want to find x. What does this length have to be? Because we know the first term of our coordinate is going to have to be 0. Could just set up a proportion again. 4 corresponds to 12. X corresponds to 6. Do a little cross multiplying. 24 equals 12x. X equals 2. So we know this distance has to be 2. If we're going down the y-axis, we have to be at -2.